Hi everyone! Today we're going to be talking about graphing systems of inequalities in two variables. So make sure you have out your notes because we're going to be doing some examples and you're going to learn how to graph these linear inequalities in two variables and find the solution set. Okay, so if you have out your notes, you can use just one sheet of paper for today and you can fold it into quarters because we're going to be doing 4 examples. Okay, and so in each of the corners, you're going to write down a set of inequalities, maybe just one inequality for the review, and then you draw the graph in that section. Okay, so we're going to start with some review. Hopefully you've seen some of this before with graphing inequalities in two variables. Here's an example problem. If I want to graph this inequality, then I first need to note that it does have two variables, which means it's going to be on a two-dimensional graph with a coordinate plane. So what are the two variables? They are, of course, x and y. Okay, and it's also helpful to look at it and say, wow, that's already in slope-intercept form because it's in the form y equals mx plus b. That's very convenient for graphing. So what is the y-intercept then? Is it m or is it b? And if you remember back to your Algebra 1 days, it is the b. It's the -1. You have to include that negative sign with the 1. It's a -1 in the inequality, but it becomes a negative when you just use it as the y-intercept. So I'm going to put that point over there at -1 on the y-axis. And then I'm going to think about my slope, which is the m in the inequality, which is 2. And notice I'm just doing this like normal. It's an inequality, but I'm kind of graphing it like it was just a regular old equation with an equal sign. Now the slope is 2, which is really 2 over 1, which is important to note because when we do rise over run, that would be up 2, right 1. So I put some points down there to get my line going. But then before we draw in the line, this is what we need to note. So if this is totally new to you, you need to write this down. So if you have a less than or a greater than, then you're not including that y value as part of the solution set. Okay? If you have the equal sign under it, that implies that there is an inclusion there, and so you could use a solid line. It's kind of like when you had inequalities in one variable and you had open circles or closed circles. That's what this is like. So we're going to use a dotted line because we've got basically an open circle kind of situation here. So I'm going to graph the line with a dotted line. And then shading. We do not shade to the left or to the right. That was for inequalities in one variable when we only have one number line. When we have two dimensions here, we're either shading above or below. And for this one, we will shade below because it's a less than symbol. If it was less than, or even if it was less than or equal to, we would shade below. And so below looks like that. Okay, so if you need a minute to pause this recording and write this problem down, this inequality, the graph, and those helpful hints up there about shading and dotted and solid lines, then go ahead and pause the recording right here. Okay, here is my second example, and this one I'd like you to think about a little bit more on your own piece of paper that you're taking notes on. So here is the inequality that you would write down, and then I want you to answer these questions really quick for me. And once you've answered them, I want you to try drawing the graph. Okay, so take a minute to pause the recording and try this problem out and see what you know. Okay, here comes the big reveal. I've got a y-intercept of -3, a slope of 2 over 5. So check your slope. Make sure that you went up 2, right 5, because it's a positive slope. And then we've got a greater than or equal to inequality symbol. So I'm using a solid line shading above because it's greater than or equal to. So check yours, make sure it looks like mine. The points that are on that line qualify as part of the solution set of ordered pairs, which when plugged in for x and y would make the inequality true. So I could pick any point in the shaded region or even on this line because the line is included. Say I pick this one. This one is -3, -3. And if I plug that in for x and y in the inequality will be true. That's what it means to have a solution set. Okay, we are ready for the new material for today. So systems of inequalities in two variables. So remember that a system involves more than one object. So in this case, we have a system of inequalities. We're just going to have more than one inequality working together at the same time. So here is our system. I've put two inequalities, and we're going to solve this system by graphing. Okay, so we're just going to start with the first inequality and graph it like we've been doing. You would write down this inequality in your notes. You'd write down both of them, actually, because we're going to graph them on the same graph. And this one has a typo. I just realized this is a 4 here. Okay, so 4x minus 1. So our y-intercept is -1. I'm going to kind of zoom through this because we've already done this a couple times now. We've got dotted line because it's a less than symbol and we're shading below the line. So here we go. Point at -1 and up 4, right 1 for our slope. Don't forget it's a dotted line. And here goes the shading. Okay, that's the first one. Now you would make sure that you have this second one in your notes. Y is greater than or equal to x plus 3. And then think to yourself, what's the y-intercept again? Oh yes, it's 3. And the slope, though, that would be the number in front of x, and there's no number there. But it's really just an invisible 1, right? The coefficient of x is 1. And this one, take a look at that inequality symbol. It's a greater than or equal to, which means it's a solid line and the shading is going to be above because of the greater than. Okay, here we go. Y-intercept at 3, slope of 1. Draw in our solid line, and we're shading above. And the new piece to all of this information is that we were trying to solve the system of inequalities. And the solution set of ordered pairs is in the overlapping region. So those are all of the points that would work in this set of inequalities. So I could pick a point anywhere, maybe this one right here, and I could plug it in. Maybe I'll do it just to prove it. This point is 3, 7. And if I plug it in here, little 7 there is less than 4 times 3 minus 1. That is indeed true. 12 minus 1 is 11. 7 is less than 11. So it made that one true. If I plug in 3 and 7 into the other one, notice I'm plugging 3 in for x and 7 in for y. I'm just checking to make sure this point actually works. Indeed, 7 is greater than or equal to 6. So this one is true. So any point in that shaded region will work in my two inequalities. This is kind of like an intersection problem if you're looking at some problems in your course. We want it to work in both of the inequalities at the same time. All right, here's our last one. This is really example 4 or example 2, depending on how you're counting them. Example 2 for our new problems. All right, so I'm going to go ahead and put up some of this. And right now I'd like you to pause the recording, try graphing this one out on your own, and then unpause it when you're ready to check. And then we'll do the second part. Okay, we're revealing what you're checking on your paper. We ended up with a slope, our y-intercept of 3 and a slope of 1/2, so up 1, right 2. Dotted line for this one because it's a greater than, and then it's shaded above because it's greater than. Okay, so now you're ready to do part 2. Pause your recording, try graphing this one now on your paper, and unpause when you're ready to check your answer. All right, we're beginning to reveal. If you weren't sure what the y-intercept would be, it would be 0 for this green inequality because it's 3x plus 0. And our shading down there. Okay, so we've got a y-intercept of 0 and a slope of 3. If you remember, when we graphed systems of equations, we just looked for the point where the lines crossed, right? But we're actually graphing systems of inequalities, so we're looking for the overlapping region of where our shading crosses. Okay, so any point in that region, if I plugged it in to the two inequalities, that point would work for both inequalities. Now, if we're on a dotted line, like right here, that point won't work. It's not going to work in one of the inequalities. It might work in the other one, but it's not going to work in one of them. So that would not be part of the solution set. As opposed to a point on a solid line, that will work. Okay, and something for you to think about is, what about this point right here? Is that one going to work in both inequalities? You might test it out and see, or think about it on your own and come to your own conclusions based on what you've learned so far. But I'm going to leave that for you. Okay, now that's it for today's session. And so I'd like you to go to join.quizzes.com and enter the game code that I sent you. Make sure that you spell quizzes correctly if you're just typing it into your web browser. And of course, use your first and your last name as your nickname. Otherwise, I will not know it's you. If you only use your first name or something that is not your name, then it will be difficult for you to have credit for the quiz because I won't know that it's you. And I want you to get credit for this. So you're awesome. Thanks for taking the time to watch this, and let me know if you have any questions about our class.